This is an example we looked at before when we look at scatter plots and correlation. So in this example you have this fat gain with respect to the x values, the change in non-exercise activities. So if you look at this scatter plots, you can see that sort of there's a trend, downward trend. Okay, so the idea now is that so you see a kind of this type of trend. Okay, so like that. So what we're trying to do is that, at least in the beginning, you're trying to kind of say, for example, draw a straight line like that. So say either you can draw it whatever that the way you think it is the best, you draw it like that. And then suppose I wanted to predict the value when the change in exercise is around 400, I need to predict the value for the amount of fat gain. So I can use that line to predict that value. So in other words, when it is 400, so I can predict that value to be that. Okay, so that kind of lines, suppose I am using a line like that, that kind of line is known as a regression line. Okay, so sometimes, you know, like this is a one variable, sometimes it's known as a simple linear regression. Linear means that a kind of a straight line. Okay, simple means one variable. So in the beginning we are looking at only one variable. So anyway, that line is known as a regression line. So it's a regression line, a line that summarizes the relationship between the response variable, which is the y, and the predictor variable, which is x. Okay, so since we are going to look into the straight lines, so I'm sure you have in your prerequisite class you have seen the straight line, properties of a straight line. So y equal a plus bx, when you write an equation like that, the value a represent basically when x equals 0 the value of y, so which is the y-intercept. Okay, so that is the y-intercept, and b represent the slope of that line. Okay, so what we are going to do is that using the data we have, we are trying to estimate these two values, the intercept as well as the slope, using our data. Okay, so then once you have that, then we can, if you want the value of y value when x equal 400, so we can use that whatever the that line. Once you know this a and b, we can put the x equal 400 here, so that we get the y value. Okay, so anyway, that kind of line is known as a regression line. So so the thing is that, so certainly you can take a pencil and draw a straight line like that. So but the thing is that we need to do it in a formal way. So there are many ways you can do it, but there's one method most people use. So the idea is that to begin with, we need to draw that line as close as possible to all these data points we have. Okay, one way to look at it is that what you do is that, say for example, this is the best line you can draw. So that best, you define it like that. Say that you look at the vertical distance from each data point to that line. Vertical distance means that for this data point, I am looking at distance from here to here. Okay, so let me go to the next page to explain that. Say this is our data. So for this data point, so this vertical distance, so this y value, which is yi, this is the data value. Okay, yi minus the value coming from the best line, whatever the best line. So that yi minus this is the value coming out of, if you're going to fit this line, so from this line the value is that, which is that. So what we are trying to do is that for each data point we take the difference, the yi minus that y coordinate, which is that, take the square and add them up for all the points, and then we get a quantity, and then try to minimize that quantity, trying to find A and B so that the sum is going to be a minimum. Okay, so that one criteria means that one way to find that A and B value. The way you figure out that A and B values, the estimates you will get out of that, or the line you get out of that, is known as a least square regression line. Least square, least mean the minimum, square, that the error term, like the actual value minus the value you coming out of the line. Okay, so that's the name of that, which is known as a least square regression line for the line. And the estimates, this A and B value you get out of that, they are known as least square estimators for those values, A and B, the intercept and the slope. Okay, so anyway, so once you have those two values, I will give you the formula for that. So once you have those, that's the criteria we will find it. Once you have those, then the line you get, which is y equal whatever the value coming out of that, a plus bx, is known as a least square regression line. Okay, so you use a hat there. So you remember that in the past you have seen that if you have a parameter like that, so if you're talking about an estimate, we use that hat. So it's like the p, the parameter is p. So if you put a hat there, it's the estimate. It's the same, the concept. Okay, so the estimated line. So actually most books you see, you even use that a hat and b hat over there. Okay, but anyway, that is the least square regression line, but that A and B you find so that in order to minimize this quantity. So you need some calculus to show that, you need more math to show that these estimators. One can show that these two A and B values, if you try to minimize that, is going to be like that, this way. So you already know how to figure out that the correlation R value, simple R value. That's what we did in the last class. Okay, so what you do is that using the data, so in other words using this data, you figure out the R value, the correlation coefficient. Okay, so once you figure out that the R value, what you do is that next for this data, the X data, you put all the X data, you put it into the memory and figure out the X bar and SX, sample standard deviation for the X values, and for the Y values, the same way you figure out Y bar and SY. Once you have those two values, and also you know how to figure out the R value. Okay, once you figure out all those three values, then what you do is that use this formula. So the B value is going to be that R times SY, the standard deviation, the sample standard deviation for Y values, divided by the sample standard deviation for X values. All right, and the A value is going to be the Y bar, which is the average for the Y values, minus the B, which is that B value, times the X bar. All right. So in other words, these are the estimated value for the slope of that line, which is the B. Okay, this one, and the intercept, this value is going to be like that. So sometimes they are known as a least square estimators for A and B. Okay, the line is known as a least square regression line. So in other words, okay, so this is the method we will use. There are other methods to find those estimators, okay? But in this class, we are going to use the least square regression line with those estimates, okay? So now if I go back to that example, this example, okay, so this example, so if you figure out the R, so the R value is going to be, we did that one before, R value is going to be minus 0.779, and if you put all the x values into the memory, the mean, the average is going to be 324.75. The standard deviation is going to be that. For the y value, those two values, okay? So then to figure out the slope, so the R, which is that, and the S, standard deviation for y, which is this value, okay, divided by the standard deviation for x, this one. So once you calculate that, that is going to be the slope. Make sure you guys keep 4 decimal places accuracy for these calculations, okay? So the slope, estimated slope is going to be that. So then you use this value in this formula, the y bar minus the b is this, which is that, times the x bar. X bar, the this slope value, the b value, and this is the y bar value, the slope value, and the x bar value. All right. So when you figure it out, then you are going to get 3.505. So that means I have the estimated values for the slope as well as the intercept. Now I have the least square regression line, which is the y hat, this one. So the a value is going to be this, minus the b value is going to be that, plus so this one is going to be the line is going to be y equal a plus bx. Okay, so this is a, this is bx. So now, say, as I said before, suppose you want the value when x equal 400. So in other words, right there, so you want to estimate this value. What will happen if the change in non-exercise activity is at 400? So all you do is that basically to predict that value, you put that 400 in there and then calculate that value using these values. All right. So then you put that the 400 for that. Okay. So for the x. So this x is 400. So that way that will give you 2.129. So at 400, that is going to be the estimated value, or the predicted value is going to be 2.129. All right. So for any values, basically any values mean you don't want to go outside of this range. By the way, you will see that why in the next video I'll show you, because you cannot rely on too much going beyond. Okay, so always you need to stay within this range, the x range, because that data goes with this x range. So the idea is we are trying to predict the y using that predictor variable, which is the x. All right. So so that's that. So we will look into basically. Okay. So okay, let me stop this video here and get into the next video. Okay. So.